Good day, everyone. It is nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel.
Good day everyone, and welcome you back to Global Education Zone. Now, we are going to be starting in this episode with scalars and vectors. So, now scalars and vectors, they are basically different kind of quantities. Scalar quantities have only magnitude, whereas vector quantities have a direction in addition to having magnitude. So, we are going to be dealing with various ways of dealing with scalars and vectors, mostly vectors. So sit right into the end and you enjoy this video. The special property of vectors is that they have both magnitude and direction. For example, let's take a man that's cycling along a path, for example. Now, you can represent the vector of his movement by a straight line which has an arrowhead indicating the direction of the given vector, and the length of the line is just proportional to the magnitude of the vector. So the longer arrows represent the bigger vector and the smaller arrows represent the smaller magnitude of the vector, and it points in the direction of the vector. So you can see that these arrows, they always point in the direction of the bicycle the man is riding. So it's a vector because it has direction and it has magnitude. So for example, if the man begins to cycle backwards now, so what do you think the direction of the vector will be? So it will be opposite. So we have two directions. We have the positive and negative directions. Depends on which one you want to use as positive. If we move the forward as positive, then the backward will be negative. If we make the forward negative, the backward will be positive, so on and so forth. Now, when we talk about addition of vectors, it becomes so similar to scalars when the vectors are on a straight line. So to add a speed of 10 km per hour to a speed of 50 km per hour, we merely sum up the two magnitudes to obtain a speed of 40 km per hour. So the reason for this is that the speeds are actually parallel; they are on a straight line. So and then the when we talk about speed, speed do not have direction. So if we're adding speed, we are merely adding speed. But when we're adding velocities, we're adding both magnitude and direction. So that's the difference between this. In the case of vectors, you can't simply rely on these kinds of drawings to understand vectors. We can't simply rely on algebraic addition. We also have to make use of vector addition or geometric addition. So in this case, we have a displacement of 3 km to from A to B. Now the reason why I say displacement is that velocity talks about displacement and not distance. Next, we have a displacement of um, 4 km from B to C. So now you have 3 from A to B and 4 from B to C. So what is the total displacement? Now, whenever you are dealing with velocity, all you need is the final and initial state. Then you connect them by a straight line. So our final state is C. Our initial position is A. When you connect A to C, that will be the vector that just represent the motion in a straight line. Now this new vector is called a resultant vector because it represents the first two motions from A to B and B to C. So when you want to represent them in a single way, you can use that AC, and that single vector is called a resultant. We'll explain more on it, but in this case, we can look for the the resultant velocity by making use of Pythagoras' theorem. And in this case, we have it as when we solve for, we have 5 km, and then when we look for the theta, we will get it as 53.13 degrees. Now, in this case, the reason why we are solving for theta is because velocity has both magnitude and direction, so the direction is the angle theta that we looked for. Now, anytime we have vectors like this and their angle between them is not a right angle, or it doesn't form the type of question we solved earlier, we can make use of a parallelogram or vector method to solve it. And in general, there are two methods of adding or compounding vectors. We have the parallelogram method and we have the triangle method. Now, when we talk about the parallelogram method, is basically means that when you have two vectors that are represented by the adjacent sides of a parallelogram, That means you can basically say that the diagonal drawn from the point of intersection of those vectors will represent the resultant. So that resultant is a single vector that will represent the original two vectors, and then that resultant, it has the magnitude of the diagonal of that parallelogram, and then you can also look for the direction. So that parallelogram method is a very handy tool. And now this is the parallelogram law in its full colors. So it states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection of the two vectors represent the resultant vectors in magnitude and direction. So what this means is that if you have two vectors that are the sides, then your diagonal will be the resultant, and you know that the diagonal runs through the parallelogram. So now, because the parallelogram law of vector addition involves one part of geometrical method of evaluation of resultant, so that is why we can make use of the cosine rule to evaluate resultants. Because whenever you're looking for the diagonal of a parallelogram, the diagonal corresponds with a side, as you can use cosine rule. You can make use of cosine rule, and this is the formula below here. So if you have the two sides as P and Q, and you have your diagonal as R, so that means you can say the square of the diagonal is equal to the addition of the square of the sides, then plus 2 times the product of the square, sorry, rather 2 times the product of the sides and the cosine of the angle between those sides. So this is the statement of how you can evaluate the resultant of two or more vectors by using the parallelogram law. The thing with physics is that when we perform a particular operation in a particular direction, it is always possible to reverse that direction. So in this case, if we can combine two vectors into one, so we can, in the same way, we can also resolve a vector into components. Now when we talk about components, we are talking about the directions of that vector. So the vectors often have two components, which is the vertical and the horizontal components. Now consider first a vector which lies in an xy plane. The vector can be expressed as a sum of two other vectors called components of the original vector. Now when we want to define a component of a vector, we can call it as in a given direction, which is the effective value of that vector in that particular direction. So when we're saying component of a particular vector in the x direction, we're trying to say that it is the value of that vector in when we evaluate it in the x or horizontal direction. And on the other hand, when we talk about component of a vector in the vertical direction, is basically the value of the vector in the vertical or y direction. Now, as I mentioned earlier, when you look for the components of vectors in direction, it's called the resolution of vectors. Now in this diagram, you can see that we have a particular vector v, and it has an angle theta to the horizontal x. Now this particular vector v, this x direction is called the horizontal component on the horizontal plane. Then when we look at the vertical direction, which is the y, that is the vertical resolution or the y component. Now in that case, it has the x component and the y component, and then the angle of the vector to the x component is theta. Now this is how resolution works, and basically in general, the x component is basically the product of the vector and the sine, rather, and the cosine of the angle, supposing that that angle is placed to the horizontal. So if that angle is between the vector and the horizontal plane, that means the horizontal component will be the product of the vector and the cosine of the angle, while the vertical component will be the product of the vector and the sine of the angle. But in general, if you have a vector and you're looking for the component of the vector, now anytime you have an angle theta with a vector and a particular direction where your source is component, the value of that vector in that direction is the product of the vector and the cosine of the angle in that direction. Now we've been able to make a very excellent case from the points where we have two vectors, or rather a particular vector, and we are resolving a vector. But what if we are resolving more than two vectors? Now to find the resultant of more than two vectors, we resolve each vector in two perpendicular directions and all the horizontal components x and all the vertical components y. For example, consider four forces acting on the body as shown in figure 1.19. Now if you see this figure now, we can add all the resolved horizontal and vertical components of each of the vectors. So what that means is you add the horizontal components of each of the vectors together to get the resultant horizontal component. Then you add the vertical components of each of the vectors to get the resultant vertical component. And then when you add them together, you will notice that they all combine to become a big vector. Now then you can now proceed to evaluate that big vector by looking for the square root of the sum of the squares of each of the resolved components. So that is how it works, and that is how to look for the resultant of two or more vectors. And then you can also get the angle of that vector by using the arctan of the ratio of the sum of the vertical to the sum of the horizontal component. Now this is a physical demonstration of what I was trying to say. So basically you are going to add all the resolved horizontal components and obtain the x, which is for the resolved horizontal component. That will be the f1 cos theta 1 plus minus f2 cos theta 2 plus minus f3 cos theta 3 plus f4 cos theta 4. That's for the resolved horizontal component. Now as you can notice, some of them have positive signs while others have negative signs. Now if you are a good mathematics student, you will know that whenever we are talking about trigonometric ratios in four quadrants, we have what we know what was known as the signs of each of those ratios. Now in the first quadrant, all the ratios are positive, while in the second, only your sine is positive, then the third, your tan is positive, then the last, your cosine is positive only. So in this case, some of them will be positive and some will be negative depending on your knowledge of your trigonometric ratios. Now if you don't know it sufficiently, you can check out the video on the in the crash physics, in the crash mathematics episode of this channel. You will see enough of that. So folks, here is an example to guide you through the process. Now in this case, we have to calculate the resultant of 5 coplanar forces of values 10 newton, 12 newtons, 16 newtons, 20 newtons, and 15 newtons, all acting on an object O, as shown in the figure. Now, this is a free body diagram, but you have each of the forces and their Cartesian directions. Now, all you need to do is you are going to look for the um, resultant of the first force, add it to the resultant of the second force, add it to the result of the third, and the result of the fourth in the horizontal direction. So when you add everything together, that will be the result horizontal components. Then you do the same for the vertical directions, you get the result vertical component. And then when you add them together, you treat those result components as new vectors. So that means you have a new vector which has its horizontal component as the resolved horizontal component of all. It's kind of like a resultant. Now then you have a new vector which is vertical component, which is equal to the resolved vertical component. Then from there you can be able to look for the magnitude and directions just from the knowing the vertical and horizontal components of the resultant. So that is how the calculation goes. And folks, we've come to the end of this episode on scalars and vectors. And just in case if you'd be interested, you could throw out this question and you can send it the answer to the WhatsApp number in the description of this video. I wish you good luck and I hope to see you in the next episode.